And as you see, it was the contradiction between the quality and the unambiguous range of measurements, this theta s. And um, solve this contradiction, we propose the structure optimization of the amplitude for antenna direction finder with high accuracy and unambiguous measurement at the same time. To do this, we propose to use 4 antennas with 4 receivers, and that have 2 wide beams and 2 narrow beams. And in this case, we have to understand the optimal algorithms of uh, signal processing. We cannot just um, subtract signals in one pair of antennas, in other pair of antennas, and then what we have to do then? To sum it, to subtract it, to divide it, and other things. That's why we will stated the optimization problem to find the optimal algorithm and what we have to do. We have stated 4 signals that we can observe against the internal noise of the receivers. In this case, also we know the complex envelope of the signal. We know the frequency of the transmitted, for example, beacon or maybe other uh, some other station, and we know that the correlation functions of this internal noise, it's a delta function. It means that this is white Gaussian noise. And in this case, we have developed the maximum likelihood function and started to search it maximum. And we got likelihood equation. In the left side of this likelihood equation, we have optimal algorithm, and on the right side, we have discrimination characteristic. And this discrimination characteristic show us the relation between the output energy of output power of our signal processing algorithms according to the variation of angles of observation, like theta s. All these angles are stated as known. And the optimal algorithm is the next. We have to weight all our measurements of energy, of power in every channel. We have to find pulse characteristics that is matched to complex envelope of the signal and frequency. Then we have to convolute all the received signals against the noise in every channel. Then this measured power we have to weight to make the to make the sum with some coefficient, and this coefficient are proportional to the diagrams. And in the case of Gaussian diagrams, we have such formula. So we have to take a characteristic of our antenna pattern for first antenna, second, in the case of its shift to the right hand, to the left hand, and some multiplication. So using these all optimal coefficients, we will get the result of corner measurements. And to understand the quality of this method, we will analyze them discrimination characteristic, the right part of likelihood equation. And this is case of when we have only 2 antennas with wide antenna patterns. In this case, we will have only this region near the central direction, we have only this linear region of possible measurements of the corner of direction of radio emission. Other directions we cannot measure, because in this case we will have unambiguous measurements and we will not understand where is the real signal. In this case, we have two antennas with narrow antenna beams, and in this case, we get high slope of our discrimination characteristics, but at the same time, it's good high slope, but at the same time, it's much narrower in generally field of view for our direction finder. In this case, we realized this algorithm, but this coefficient we choose the same in every channel. And in this case, you see that we generally did not get a better result for antenna direction finder. But when we have just all these coefficients according to this form, optimal one, we've got the wider range of unambiguous measurement of direction. It become wider. It's become wider at least 2 times, but the slope of this characteristic, it become not the same form in this range. We've got a relatively worse characteristic of direction measurements, but we got a much wider direction of unambiguous measurements. And if we implement automation of control UAV on our aircraft, so after some time it will fly to this equal to this point of equal signals when we get the same signal from 4 channels. And in this case, you see, when we come to this part of discrimination characteristics, we will have like relatively high quality of measurements. But in this part, it's not high, but still it can work. And then we decided to go further and proposed the direction finder with the highest quality of direction measurements, but with the narrowest region of unambiguous measurements.